Hello everyone, this is Jay Wingrow and welcome to Think Like a Software Engineer, episode 14. When code isn't working the way you'd expect it to, an important technique in the software engineer's toolbox is to isolate the problem by checking each component within the larger system. Let me show you what I mean. One of life's most frustrating problems is when your phone doesn't charge. My phone isn't charging! Right. The technique of isolating the problem first begins by identifying all the components inside the system. In this example case, let's say the system of charging our phone can be broken down into several major components as follows. The first component is our phone. Of course, the phone consists of many smaller parts, but we are identifying the major components of our system. The second component is our cable. The third component is our wall charger. And there's actually a fourth component as well if you think about it, and that is the wall socket that we're plugging this all into. These four components make up our technical system. And if any one of these four individual components is defunct, our phone will not charge. So what we have to do next is to isolate the problem using a technique that I call swap and test. To swap and test, we take each component of the system one at a time and swap that component for an identical component that we presume to be working. So we can do this in any particular order. Let's start from the wall socket and work our way towards the phone. So to swap and test the wall socket, we'd swap out the wall socket we've been trying with a different wall socket. So that means we would take our phone cable and charger and plug it into another wall socket. If the phone starts charging now, we've successfully isolated the problem by realizing that it was our original wall socket that wasn't working. If, however, our phone still isn't charging, then we have not yet isolated the problematic component, so we have to move on to the next one. So let's swap and test our wall charger with another one. If our phone begins charging now, we can conclude that our original wall charger was the problem. If, however, the phone still isn't charging, then we have to move on. Let's swap and test our cable. If, with the new cable, the phone charges, that means that the old cable was the problem. If, however, the phone still doesn't charge, then it would appear that the problem is with our final component, being our phone. Now, as a sanity check, we should also swap and test the phone itself. So let's plug in a different phone into our socket charger cable system. And if this new phone is charging, that would certainly indicate that something is wrong with the original phone itself, which, is the worst possible outcome. This technique of isolating the problem by identifying the subcomponents and swapping and testing each component is critical for debugging code. Why? Because your code is made up of more than one component. How do I know that? Because as soon as you have two lines of code, that means that you have at least two different components. You have two possible points of failure. The failure can be happening within either line of code. In some future episodes, we will demonstrate this technique on actual code. But for now, I want you to adopt this mindset of how to isolate the subcomponents of any technical system, and you can use this to solve all sorts of technical problems. I look forward to joining you again next week.